Okay. All right. Thank you very much. Thanks for Intel and the organizers to invite us here, and also thank all of you. I hope you're not very hungry right now. I also would like to thank actually the previous two speakers because they did a great introduction to our topic today. Yeah. All right. So my name is Dan, and I also brought my colleague Kai Hübner, and we are co-founder of a Stockholm-based tech company called Gleechi. And today we will talk about our hands in games. A little bit background about ourselves. So yeah, we are the hipsters and hackers of the company, and actually Kai and I share quite many similar backgrounds. We are both PhD, though we are in different fields, biomedical engineering. I did neuroscience to study how brain controls our movement, and Kai did PhD in computer science and robotics. And then we met here at KTH in Stockholm, and we were doing research in robotics, in intelligent robotics, working on two big EU projects. And then later we have some industry experiences. We're using computer vision technologies to different applications like the sports broadcasting and Tobii eye tracking technology. But actually what we are doing at Gleechi is based on what we did, our research at KTH, primarily about we want to teach the robot to use the robotic hand to interact with the object in the world. And how do you do that? The robot is equipped with, is this playing? Yeah, it's equipped with 3D camera. No, the cameras on the head, and then it looks around the environment and finds the objects. And then it forms some kind of 3D representation, and then use their robotic hand to decide how to grasp the object so that it can pick it up. But to interact with the environment, it's not just to picking up things. The most important thing actually is what do you do afterwards? You pick up something to do something. So actually what we are focused on, or we have focused on in our research, is to study how to link this intention, what do you want to do afterwards, to decide how the robots should put a hand around the object. So for example, if you want to do a pouring task, you want to pour some water out of this cup, or if you want to drink with this cup, you don't want to grasp this object from the top. But if you want to give this object to another person, then you want to maybe expose the handle part so that the other person can reach it. So the important thing actually is the intention. And what we did is to consider this intention, consider the objects, and also consider what kind of hand the robot has. So sometimes the robot has a two-fingered hand, sometimes it looks like a human hand, like this one. So we consider all this constraint and design. We have an algorithm that looks like, that functions like a human brain to decide what kind of grasp should be applied on these objects. So, well, maybe you have a question mark in your head why we are here. I'm talking about robotics, but this is a game conference. But if you think about it, actually the avatar, you cannot play a game without avatar. So if you have avatar, and the avatar need to interact with the game environment, and avatar actually is just like robots. We want them to interact. And how to interact? For us, we interact with the world with our hands. This is our fundamental tools to interact. And we also want the avatar to do the same. So we have done our research to teach robots to interact with objects in the physical world. But we have actually at Gleechi have successfully converted this technology in our research to the virtual world so that we can teach the avatar, just like a robot, to interact in the digital world, the digital object that you created in a game environment. So that's why we call our technology virtual grasp. So I've been talking about how to apply it in the game world. Let's look at how it looks like in the games. Back in 2003, in Second Life, Linden Lab, and you see that this avatar is clearly want to interact with the object. I think this is the cash machine, And you see that the body is very rigid, the hand is very rigid, and it doesn't really do the things as you expect. So, well, it doesn't even do as good as our robots that I showed to you. Of course, you can say that it's like more than 10 years ago, and that things should improve. And let's look at 2009. And I think a lot of games, I mean, you are all game enthusiastic, you're all hardcore gamers probably. And a lot of games is to, actually the avatar is just grasping some kind of weapon, a fixed set of weapon, whether it's a knife or if it's a gun. And all the hand motion involved in these games is actually canned animation. So you do animation once and you apply it over and over again on the same object in the same way. And it will become very interesting if actually in some games you do want to interact with many objects, like this one, Skyrim. So you need to interact with hundreds of objects in the environment, but what happens is the hands are still just floating there. It doesn't really do things like you do in the real world. Objects just magically disappeared and do the things that you want them to do. So wouldn't it be great if you actually can allow this avatar can do things like what you do in the real world? But it's quite difficult. And now we're talking about just last year. Things actually didn't happen so much in terms of the hand interaction in the game world. Why is that? The technology and the computation power has evolved very much, but why there is still no hand interaction? Oh, I would like to show this more fun picture. In fact, the same problems also exist, same answers also exist in the general animation industry for for animated films. No matter if it's a 3D animation like Pixar's animation or it's just the traditional 2D drawings. I don't know if you have ever tried to draw your own hands. If you just grab a pen and try to draw on the paper your own 5-fingered hands, you will notice this is extremely difficult object to draw. And if you notice that in these images, there are something in common, is they have only 4 or 3-fingered hands. It's not 5-fingered hands. Why is that? Because hands is the most complex mechanical structure among all of the different body parts in our body. So it's extremely difficult to animate. This is actually a very famous image in neuroscience. I don't know if you have seen it. It looks a bit ugly. But this is the different body parts of this image is drawn in a size that is proportional to how much brain power is needed to process it. So maybe since we are in a game conference, this is more fun. This is actually the bug. It's a huge hand glitch. But finally, it seems that the game engine behind FIFA 2014 also thinks like the human brain. They know that hands is really difficult. So let's come back to animation. Probably all of you know Mixamo. They provide the animated, the animation database and also rigged avatars to developers. And if you just look at the different options, with and without hands. With hands, you have 65 total number of joints, and it almost triples when you don't have hands. So what this means is that if you want to animate hands, it creates an enormous amount of effort for you to do it. So this is the example of someone trying to animate this FPS handy hands from Unit Asset Store, and you see that you have to manually tweak each individual joints and move the object inside it so that you create a realistic hand animation. Well, in fact, the hand doesn't even move so much, it's just grasping this object. And with all this effort, what did you just achieve? It's just one single hand grasping one single object and one single way. So you can imagine if you really are in the more interactive scenario, you really want to grasp all kinds of objects, probably with using different kind of hands, if you have multiple avatars, and then you want to grasp things in a different way because you want to change the way you grasp it in order to do something. And what happens is like this. You will kill a patient instead of helping them. So what I want to show here is when you want to really do an interactive scenario in real time with your hands, grasping different things in different ways, the effort of animation will grow exponentially. So it's really impossible. So what you will choose to do in this situation is just to ignore it. And that somehow explains why nowadays there are still no hands. So if you, I think people have been talking a lot about virtual reality. If you have a headset, the visual is fantastic. It's really impressive. But when you see some interesting object in front of you, what you immediately want to do is to raise up your hand. And you will not be satisfied by just flipping things around with your hand. You want to grasp it, right? You want to play with it. And if the play, can I play this again? When you interact with object, when you really want to have immersive experience, suddenly you see your own hand is sticking with object. And this immediately breaks the sense of immersion. So you do want to have a natural interaction, isn't it? Right? So to summarize the problems, I think especially relevant to you guys who develop games, want to have fantastic games out there, it's really difficult and time-consuming whenever you want to involve the hands interacting with the objects. And especially when you want to develop a game that involves real-time interaction with any kind of objects, with any kind of hands, then the result is often non-realistic. And the third one would be more like a question to you guys. Do you think liking hand interaction in the game will restrict the involvement or the evolution of the games? So if you look at this example, the Tomb Raider franchise, so we see that the computer graphics, the technology has evolved for the past 20 years in a very, very impressive state. So from the very pixelized avatar like that, rigid, to really real human look, nice hair, great facial expression. But what is missing is really no hand interaction. It sounds like, it appears like nobody really cares about hand interaction. Is that really true? That's the question. Really? We can discuss about it later. Yeah. But maybe you don't care, but certainly there are somebody cares. And somebody who is really an industry leader and has a great impact on the evolvement of this industry. So this is a quote back in 2009, or 6 or 7 years ago. So he says that improvements to software and higher computation speeds has made it very realistic environment and make very refined face motions. But hand movement, for example, is still at a very crude state. So the problem is there, and people want to solve it. It's just being hidden. In the recent example, we all know about virtual reality, and there was a television interview of Paul Locke, and he said that the moment you wear the goggle, you would like to interact with the virtual world, just like you do in the real world. So what if we have something to realize this ambition? We can enable everyone to easily use our hands, which is the fundamental tool for us to interact with the real world, also to interact in the virtual world. So that's somehow closed loop, and we have this technology called virtual grasp, and our ambition is to solve this problem. Not only for you guys as a game developer, and we also want the gamers to experience this fantastic tool, the hands, for ourselves. So here is a little video demo with this virtual grasp technology. So you can interact with any objects in front of you in the game world in a realistic way. You can grasp whatever way you want. You can play with the dice like this. Or you can grab a mop and even clean a mop. So I think my colleague Kai will talk a bit how we do this.
Introducing, and also for the previous speakers of Intel and also the VR talk, so that we don't have to talk so much about VR anymore. But so how does it work to add this a bit more? Because I mean, I was here last year and I felt there were a lot of game developers. How many game developers are here actually? How many of you? Oh, quite a lot. Okay, so then I don't have to leave. I actually have something to talk about. So how does it work? When we talk about robots, as Dan said, to go back a bit in the loop here, everything starts with a task. The robot has to know what to do before actually looking into its own hand, trying to see the objects that are around the table, interpreting the world, interpreting this information, and then finally actually do something with it. That's like the process usually in robotics. In gaming, it's often a bit the other way around. I mean, when we talk about hands and interaction, it often starts at the motion controller. You have some kind of input, some kind of controller, and you try to steer the rig, your hand rig, in a way. So there are two things here to point out. One thing is that you actually miss quite a lot of contextual information when you just focus on the motion controller and the rig. And the other point is that you start at the other end. Somehow you start at the motion controller and not at the task, at the intention. So you could say everything starts with an input. That's what all the people say when you want to talk about hands in games. We say that actually everything starts with an intention. You want to pick something up. You want to interact with objects in different ways. And there's where we start. And I mean, the one question is, I guess, I mean, we had a lot of VR systems here today already on the slide, but when you want to start with putting your hands into a game, you can use RealSense, as we saw. We actually have the earlier RealSense camera here. It was a perceptual computing SDK that when you could use 3D camera, Leap Motion, Mayo. I don't know if you know this one. It's like a graphic sensor to measure signals in your arm. You could even use Sony Move, for example, or a regular game controller, or for Tobii people, an eye tracker, to just have some intention about how do you interact with games. So there's all this big mass of things, and almost every new month something else comes up. I think, of course, you would ask, what's the best? Of course, Intel is the best. But I mean, it depends clearly on the application. I mean, you have gloves, you have 3D cameras, you have game controllers, and maybe even when two of you talk to each other, you have different preferences. Like, I mean, do you need finger tracking in your application? Do you need feedback? Or do you want to have like convenience of a regular game controller? And I'll skip that one. Because what you have there, or maybe I go back a bit, because then when you as a game developer have to decide, that means you have to program your game for a specific game controller, and your game will maybe only support part of the users. So somehow the user base is defragmented for you because you need something for each particular hardware piece. And with Virtual Grasp, our goal is actually to provide an intention-based, as I said before, intention is a buzzword or keyword here, device agnostic, which means that you could use any kind of device to actually give an intention to the system. All of these devices here, or just your mobile phone, for example, to give some, or you could also use speech, text, whatever, if you just tell the other, or you can use a mouse, a keyboard, click on something. Because the main thing is a software solution for hand animation. And hand animation can be used in different ways, games, applications. About what we are currently doing, how we are working at Gleechi is that we are currently working on customized experiences with project partners to deliver first use cases. And what we notice actually that while in gaming, as you might understand, you don't necessarily today see the need that when you have a shooter, okay, you pick up your gun in one way. But with upcoming virtual reality, for example, you might want to interact freely with objects. And that's why we're currently seeing or working together with so-called serious games companies. Serious games are games that are not for entertainment, but for example, like simulation, education, or rehabilitation. So we are currently working on a project like this one, where you have a glove, a haptic glove. It's not this Gloria hard, this is just an example, where you have some visual feedback on the screen of a hand that actually interacts with the objects in a natural way, while the patient actually cannot. But maybe for you it's more interesting, a midterm solution that we are aiming for next year is to implement a scalable plugin solution for the regular game engines, Unity, Unreal Engine, Havok, but also animation studios. And we are thinking about a similar model like Mixamo, which you might know, that you have some more web-based business model where you can just download a plugin and I mean, you as a game developer, you have your objects. Maybe you have hands, maybe you have not, so we can support you in with auto-regging tools. And the plan is to provide some kind of freemium model for indie developers to bring this out. So this is currently our core team. Dan and me, you know, and Jakob is our CEO. He's currently lying on the beach somewhere in Italy. But we are also thinking about extending our team. Currently we have 2 master thesis proposals, one more in the technical. So if some of you are interested, or also in some other technical task, contact us. But also in the marketing side, we currently have a master thesis mainly into the health industry, but also VR. We want to analyze the market. So to finish up, I'd like to thank all of you, also for the organizers, for organizing this great event. Here are our sponsors. If you have questions, you can ask Dan and me, or send us an email. And I also finally want to invite you to the Stockholm VR Meetups next round, which is in a month from now, which we are also organizing. And this time we will have an exhibition, so no presentations, but like very local VR companies, around 10, a dozen, will show their latest and greatest. And I think it's already booked out, but I think if you sign up, we maybe split the event into 2, so that we have 2 different batches. Okay, that was it. Thank you.